Hello everyone, in this particular video we are going to try and understand what is accuracy, and we are also going to calculate accuracy given a confusion matrix. So accuracy can be thought of as the fraction of correct predictions that are done by our model. So we can formulate it as number of correct predictions divided by total number of predictions. If we take the case of a binary classification problem where the classes are positive and negative, we can define accuracy as the sum of true positive plus true negative divided by the total number of predictions. Now, what is the issue with accuracy? So the problem with accuracy arises when we take the case of an imbalanced data set. So we'll directly get to the example here, which says you can consider a data set of 100 individuals where we want to predict if an individual is suffering from cancer. The data set has 90 individuals who do not suffer from cancer, we are going to call it as class 0, and 10 individuals who do suffer from cancer, so class 1. Now if we build a model that always predicts the label to be class 0, then our model is going to end up having a high accuracy, because 90 individuals are of class 0 and we have predicted for all 100 we have predicted that it is class 0, so at least 90 of those instances it is going to be correct. So 90 instances are correct divided by 100 total instances, giving us an accuracy value of 0.9. However, it is a bad model because it is never going to be able to predict when an individual is actually suffering from cancer. So because of this, in such cases we are also going to have to be dependent on other evaluation metrics. Now let us have a look at how to calculate accuracy in sklearn. So we have the accuracy score function and from the module sklearn.metrics, and it primarily takes 4 parameters: the ytrue, ypred which is the true label, ypred which is the labels that are returned by the model, and then we have 2 more parameters. The important ones are ytrue and ypred here. So here if you take ytrue and ypred, the two lists, and if you pass them to the function accuracy score, it returns the value 0.5. That is because we have 0 and 0 and 3 and 3 here. 2 of those predictions are correct out of 4 total, which is why 2 by 4 gives us an accuracy score of 0.5. So the parameter normalize is going to give us the count of correctly classified samples, whereas if you want to weigh a particular instance more than the other, then you can assign sample weight. Now if we look at the value of accuracy on a real world data set, we are going to use KNN model on the breast cancer data set. We first do the necessary imports, we split the data and train and test, and then we fit the model on xtrain and ytrain. Then we can directly use model.score. For a classification problem, model.score directly gives us the accuracy value. If not, we can also find ypred and then pass ytest and ypred through the accuracy score function as we did previously. The value that we have is 0.965. Let us also print out the confusion matrix using the confusion matrix display function, and this is the confusion matrix that we have. So when we manually calculate the value of accuracy, we have the same confusion matrix here. If we take class 1 to be positive and class 0 to be negative, we have 88 true positive values. That is, the true label is 1 and predicted label is 1, and 50 true negative values. True label is 0 and predicted label is 0. 4 values where the model has falsely predicted it as positive, so false positive is 4, and 1 false negative where it has falsely predicted it as negative. Now we can substitute these values in the formula for accuracy, and we are also going to end up getting a value of 0.965, which is same as that obtained in the sklearn function. So that is it for this video. Thank you.